Hello and welcome back. Today I want to do some unboxing for you guys. If someone is in the chat box, can you tell me if the sound is okay? Oops. So I'll stop. Yeah, it should be fine. I can hear it from my laptop down here. Right, the main purpose of today's live stream is to go through some of the electrical stuff that have arrived over the past few days. Some of them came a few months back actually. So I'll be looking through some of the boxes that I received from Beckhoff, and I'll go through why I actually decided to go with this manufacturer of servo motors and the controller system. I've received quite a few boxes from Beckhoff just last week. Let's start unboxing them. So the main reason I decided to go with Beckhoff is that Beckhoff, they are very famous in the world of automation. People don't seem to know them when it comes to CNC machines. From what I understand, the CNC side of Beckhoff was originally developed by another company, ESG or something. They're still in the business. So most of the CNC applications using the Beckhoff technology has been developed by that company, not Beckhoff themselves. But everything is based on the Beckhoff platform. So what is the Beckhoff platform? Beckhoff is an automation company. They've been around for over 30 years, maybe around 40 years. It's a privately owned company. They're German. It's owned by Mr. Beckhoff, and so they've been around for a few decades now. They got famous for their bus system, which they developed a few years back. It's called EtherCAT. This system is an Ethernet-based communication bus, and it's quite a famous one in today's market. The reason being, it's very fast, it's reliable, you can have plenty of nodes, and they kept updating it. And it wasn't something like those bus systems that you can see from various manufacturers like Siemens, Fanuc, and etc., that were proprietary to that brand. Beckhoff actually decided to share this platform with everyone else. So this is what I understand. It might be not 100% technically correct, but they told the manufacturers of PLCs, servo motors, drives, inverters, I/O cards, various companies to come and use our platform and our bus communication system. You just have to buy the license from us, or sometimes even the EtherCAT chip and use that inside your product, and then you will be able to communicate with a whole host of other products. So for example, you can have a servo motor from one brand, a different inverter VFD drive from another brand, a PLC from another brand, and in theory they should work seamlessly together when you are using EtherCAT. I know that it hasn't been the case for everyone, but that's the whole idea behind this Beckhoff ecosystem. So the bus connection is called EtherCAT. On the other side, they do have their own PC-based PLC and automation controller. It's a software called TwinCAT. It's been around for over 20 years at least, I would say. and it's a Windows-based platform that you can write your program on it. So you can have like a PLC controller, you can have a motion controller, you can have a full automation system developed within that system, the TwinCAT system, and then you can run a huge factory with that. It also has a motion controller function inside, which is something that we're interested in. And it has a CNC function baked into that motion control side of TwinCAT. So that company that I told you about, the other company, I think it's called ESG, I'm not sure, they worked on the CNC side of TwinCAT, and they developed it, and they were offering that to manufacturers of CNC machine tools. So they were saying that we will develop a controller based on, or a CNC control based on TwinCAT. You can use Beckhoff technology with regards to servo drive, servo motors, and then we will make the interface look like your own CNC control. And underneath it's always Beckhoff and TwinCAT working, but the HMI side of it, what the user is actually interacting with, it's all it belongs to the CNC machine manufacturer, and that was the whole idea behind it. And then they did that for quite a few years, and they got some good manufacturers on board, whether in the woodworking machinery industry or whether in a metalworking machinery industry. So they've got good samples of users. And then they decided to sort of release it within the TwinCAT software package. So you can actually use the CNC function without the need of any third-party company to help you out with. So the documentation is all there. The functionality for various things, it's already prepared and done and dusted, so you just have to download the different modules and then install them on the TwinCAT system, and then just tweak the parameters based on your specific machine, and then it should work. You can run the TwinCAT software on any type of Windows-based computer, and then use the Ethernet port to communicate with your servo drives and motors. But when I spoke with the Beckhoff people here in the UK, they said that would work for your testing phase, but if you're running a 5-axis machine, then the delay time of those because your computer is not real time, your Windows is just running tasks one after the other. For a CNC application, you can't have that. So they produce industrial PCs themselves. So that's one of the main businesses of Beckhoff. So I decided to go with their own computer as well, just to be on the safe side. It's a Windows-based computer, but it's in an industrial format, and they designed the BIOS, and they work with Windows actually to create a real-time system, which is what you need for a CNC machine application. And then I could have used servo drives and servo motors from other companies, but then in the end I decided to just go for Beckhoff everything. It was a lot more money than what I anticipated. It was a much bigger investment, but I hope it will pay it off and it will be a good choice. So that was the whole idea behind it. So the control is TwinCAT based Beckhoff, and then the servo drives and servo motors are also from Beckhoff. The only exception is for the 2 rotary axes, because Beckhoff does not produce torque motors or torque motors. So they produce linear motors and sort of normal brushless rotary type servo motors as well, but they don't produce a torque motor as such. So I decided to go with another manufacturer that I know called CPC. I've received their products months ago. So I've already opened them. I haven't opened these Beckhoff boxes yet, but I've already opened them. I will show you some of the CPC stuff as well. Right, with that long introduction, let's get into it. Right, I'll just adjust the angle of this camera. So, yeah, that should be good. Should be okay. I'll just put this to the side. Yeah, there we go. You can see that clearly now. I don't know what's inside these boxes, to be honest, so... Ooh. Is that the computer? Yeah, that is the computer. So this is the brains of the stuff. Interesting packaging. So it's a cardboard box, and they vacuum pressed this computer inside of it, and it's kind of suspended midair. So I don't want to open this box because I'm not sure when I want to install it. So, but I'll show it to you. So this is the computer. It's looks nice actually. So I think this is a Core i7, the one that I went for in the end, or Core yeah, it's a Core i5 CPU, 11500, 2.6 gigahertz. I went for 8 gigs of RAM, and then there's 40 gigabytes of SSD in this. I think this is a fanless computer, if I'm not mistaken. I mean, look at the size of that heatsink. So you've got 4 ports here, which you can use for either LAN or Ethercat. And there's 4 USB 3 ports and 2 display ports, so you can have 2 monitors with this. So yeah, that's the brains of it. This is very expensive, I tell you, so better be careful with it. So there's that. There's our computer. I'll just put a little bit of tape on it so no dust or anything would go into it. Alright. So that's the brains. Right. What's this big boy? Cables, I think. Gosh, these are big, thick cables. Wow. Very thick cables. I probably need to rethink the size of the energy chains. Oh God, wow. I mean, these are beefy. Look at the size of this thing next to my finger. Wow. So, one interesting fact about the Beckhoff system is that the cables for the motors and the drives, it's all in one cable. So they call it OCT, or one cable technology. So they've got one cable that transfers the power lines, the encoder output, and the sensors. So and the brakes. So, for example, your temperature sensor, if you've got any auxiliary sensors, it all come through one cable, as well as your power and your, what's the name of it? Power and brakes. Yeah, so these are just our cables. Oh, there's some extra bits down here. I'm not sure what these are. I want to say these are some connectors for the end bits, or maybe these are some cards. Oh right, yeah, no, these are actually some EtherCAT cards, I reckon. Right. Yeah, there must be cards. Yeah. Right. So what's that? Yeah. Okay. See this? This is a Servo. Oh, sorry, not a Servo. This is a stepper drive that goes like a module next to the PLC modules of the Beckhoff system. So it's a stepper drive, this one. As you can see, very, very compact. Nice. There's one in that one. There's quite a few terminals down here. I bought loads of I/O stuff. They all look the same, so I'm not going to open them up. These are I/O cards. What else do we have down here? There's more I/O stuff. I think this is the base coupler, which they call it, the EtherCAT coupler. I'm going to open this one just to show it to you. So this is the first card of your what you call it, PLC modules. So what the idea is you mount this on a DIN rail. So your DIN rail goes in there. You mount this on a DIN rail, and then you slide other cards next to this, and then with one of these EtherCAT connections, you just connect it to your controller, the computer that we just saw, and then the other one goes into your next devices, which is going to be our sort of servo drives and other stuff. So yeah, this is the coupler, which brings the power line and the EtherCAT to the other modules on the system. So yeah, just loads of I/O bits and bobs, more I/O cards, and then just an end cap. There it is. Interesting stuff. The packaging is alright so far. I mean, I've seen better, and if you've watched my previous video, I've seen much worse as well. Right, I'll just put a little bit of tape. The reason I'm closing these is that I'm not making the electrical cabinet just yet. It might be in a few months from now, so just to prevent dust getting in. All right, cool. In here, it's a box in a box. Let me just put this to the side. I want to say this is one of the drives. Could be a motor, I don't know. Yep, it's drive. Same type of packaging. which is vacuum sealed of these. So this is one of the servo drives. Each of these controls 2 channels, so two drives in one package. As such, yeah, looks cool. There's some extra bits underneath. Let's see, what else do we have under this? Ooh, look at this, beefy manuals. Printed ones. Cool, huh? Okay. Thank you, Mr. Beckhoff. I like that. So let's just close that up. These are proper boxes, these are. You know what, I'm gonna open this big box on the side and then bring the goods up there on the desk. I want to say this is the same stuff, but it may not be. I've got 2 of these drives that you saw. One of them will be for the X and Y axis. The other one is going to be for the Z axis and the spindle. Yep. Same stuff on this one. So another drive. All right. Put that to the side. Yeah, proper packaging for these. All right. So this is another one. One of these is a power. What do you call it? A power module. So the drives themselves, you can't connect your mains power directly to them. So one of these is just a power module. They all look the same, to be honest, so I can't really tell which one is which. Probably the previous one we opened up was the power module, because on the power module you would have the EtherCAT connections as well. So yeah, they all look the same, like I said. All right. Where's my tape? Only one box left, and that must be the motors, which is the heaviest box. The motors are nearly identical, so I'm not going to open all three. Nice tabs. They open up in an angle. Alright. Oh, okay. Ooh. Foamy bits. Right, this is 2.737 Newton meters, 6,000 RPM, 1.38 kilowatts of peak. And there we are, a servo motor. Just trying to get rid of this tape on my finger. Yeah, might be a bit oily, which it is. So yeah, one beefy long servo motor. How do you open this? Turn? Was it pull? I think it's just pull. So that's your connection. These have, if I'm not mistaken, 24-bit encoders. And this is, I went for a smooth shaft. I hope it's a correct one. If I can get rid of this jacket, yeah. So it's a smooth shaft rather than a keyway shaft. Interesting, it doesn't have the seal on top of it. Not that it needs it, because maybe it's because of the RPM, because it's a high RPM servo. But and then there's the bearing, but the bearing itself is sealed, so that should be enough. Can I rotate the shaft? It's not actually rotating. Interesting. Don't think this one has a brake on it. It might have. Doesn't look like it. Doesn't have a brake module as such. But yeah. Ooh, is that a QR code? I think that's a QR code. That's a serial number and a QR code. It's one beefy motor. Yeah, whenever I'm selecting servo motors, whether it's servo or steppers, I usually tend to go with a more substantial size, a bigger one, because yeah, you can't go wrong with going with a bigger servo motor, really, because then you can limit the torque, but if you go under it, if you go below the amount that you need, then you're a bit stuck, aren't you? So, all right, what's that? Right, is that to remove a pulley or a gear? Yeah. Yeah, well, cool. Interesting packaging, I'll tell you. Nice stuff. Yeah, I'm not going to open the other two. Because it's the same thing, really. So it would be boring. Oh well. Yeah, my tiny workshop is, or garage I should say, is getting filled up with boxes. So let's go and have a look at the CPC stuff, right? Because I promised you that. And I might show you the spindle as well if I don't forget it. Right, so this is the encoders for those two A and C axes. Look at the size of this box. Okay, I mean these are wood on the side of it, and then they wrapped it like this, and then inside of this is a disc. Have I not opened it? There's another one. Ah, okay, you can see it like that. So that's your encoder disc. It's a piece of glass. Really nothing special to it. 1 millimeter thick piece of glass. I've got no idea how I'm going to glue this to the shaft. I hope I don't break this. But yeah, so that's your CPC encoders right there. And I've got two of them, obviously, one for each axis. These are multi-turn, what you call it, multi-turn absolute encoders. Ooh, dust. The Beckhoff motors, they have absolute encoders as well, but they're single turn because I will be using linear scales as well. Dusty. Right. So. So this is one of the CPC drives. I've got two of these, obviously, one for each axis. They don't have twin channel drives. So yeah, one of them, this is the small one. There's another one which is a lot more beefy. Yeah, these have EtherCAT connection. If I can find it, there you go. So that's your EtherCAT connection right there. Your EtherCAT in and EtherCAT out. It should work seamlessly with the Beckhoff controller, but we will see that when we install these. So yeah, servo drive. I think this is a 9 amp output, and there's another 20 amp or something, much bigger. tape. Okay, yeah, this is just cables and encoders. These are also encoders. I'm not going to open encoders again because you've seen them. Right. See what's that. Right, these are the direct drives. So I'm just going to show one of them to you. Actually, they're both the same thing. This is for the C-axis. So these are custom built. Yeah, these are custom built to the spec that I asked them to do. So this can go up to 7,000 RPM. I think it's like, I don't know, 12, 15 Newton meters continuous power, and then triple that amount as a peak. Let's see what's in that one. This is the rotor. Yeah, that's the rotor. So that was the stator, and this is the rotor with the magnets. I mean, look, the packaging is just fantastic. I mean, nothing's going to happen if you throw this from a 10-story building. Nothing's going to happen to it. And every single thing came with an inspection report. Obviously I haven't tested these yet, but this is a good company, CPC. I've tested other products from them, linear drives, but sorry, not linear drives, linear guideways. But yeah, this is the tolerances inspection. So every single thing is custom built and is inspected. And I have to say that they forgot to deliver one of the encoders, but then I got in touch with them and they said sorry about that, and they shipped another one right away. The encoder, how do you call it? The encoder read head arrived, but the disc was missing. Oh yeah, they sent another one right away, so we're good. Right. Okay. So you've seen that. Just put these back. Right, the spindle is the one that you haven't seen yet. Where do I have the spindle? Okay. Out of dust. I've opened this up 2 or 3 times. But it's worth having a look. Oh, this is a box in a box. Okay. Let me just put this aside. Right. So right, this baby here is a 60,000 RPM, 1.8 kilowatt closed loop T11 automatic tool changing water cooled spindle. Right, that was a mouthful. Right, let's have a quick look. So that's it. Teeny tiny dinky spindle. That's your spindle nose right there. 60,000 RPM, as I said. Loads of cables and connectors. And yeah. Let me see if I can find one of them tool holders for you, because that's the cute part. So this will be controlled by the Beckhoff drive as well. So it will be controlled like a closed loop motor. And this is a T11, which is based on an ISO 10 tool changer, or tool holder rather. There we go. I mean, that's cute, isn't it? You can just use these on a keychain. Well, look at the size of this thing. Very dinky. So, yeah. Next to my thumb. So yeah, I think this can hold up to 8mm, 7 or 8mm diameter tools. It's an ER11. ER11 is up to 7mm, I think. Yeah. So that's your tool holder, and that was the spindle. Do you know what? Now that I've got this open, I want to see the spindle holder. Let's do that. Wasn't that hard to get this to this one. So this afternoon I want to lap this surface against the other mating surface. So I will be putting another video. I'll just do another live, and then we will do the lapping together. So this is the spindle holder. I can get rid of this. Let's see if we can mount this. You know what? I'm just limited in space. I'll just get rid of that and then put this to the side. So I think I've got like 0.2 millimeter of clearance or 0.1 millimeter of clearance. So this should just slide in, he says. Well, it is going in, but yeah, that needed a wipe. Should have done that. Should have not done that. Ooh. Ow. Yeah, it'll go in. So that's what you need to know. It will go in. So yeah, these are your inputs and outputs for various channels. Like you've got a water in, water out, and then you've got a couple of air connections, this and that. And then I just scratch that. It won't be visible, but oops. So this is aluminium, that's stainless, so it will leave a mark. But yeah, it will go through, so that's what we needed to know. Let me just try it from this side as well. Yeah, it does go through. And obviously you can just like shove something in between this and open it up a bit. So that was the spindle. So my plan is to do the lapping on this. Let me just bring up the mating surface as well. Let me just find that. All right, there it is. So, I think one of these had a nick. I think it's this one. I'll just bring up a file. So yeah, this one has a slight, I mean this has been, I don't know, bashed against something else, so it's got a little bit of Yeah, that's clean now. And then this one also has, yeah, a tiny little dent. Maybe you can't see it. And there's another one here, so I'll just remove them. Right. Okay, it's good now. There's a scratch there, but yeah, this one has a few scratches as well. So the idea, as you might have seen in the previous video that I had, is just to mount these two together. They have to be perfect mating faces. I mean, the radius seems okay now, but it just shifts and moves a bit. It wants to sit in a... It wants to sit here. So that means the radius, the radii are not exactly the same. It kind of grabs, but not fully. So what I want to do is to mount this or tape this to a desk or something, and then apply some ink first, and then just move this alongside, like up and down, to see if we can find the high spots. If we can, if we see there are some high spots, then we will apply some lapping paste. I mean, you can see it kind of grabs, and it just, but not fully. So we will try to lap these two together, so they would have the best possible mating surface. So the idea of having these two is, when you are mounting the different axes on top of each other, you will have a tolerance stacking effect. Obviously we've tried to machine everything and lap everything as good as possible, but it won't be perfect. So the idea is to allow for some adjustments when you assemble the whole machine. So this face, which is a very, very good surface finish, this face will sit against the granite on the Z-axis, and the spindle obviously goes in here, and we will have some setting screws all around this that would allow to move this up and down. When you move this up and down, this is stationary and this is going up and down, then the spindle nose will go back and forth. So then with some like either a laser measurement or with a granite square and just a DTI, you can clock this to have the perfect amount of perpendicularity with the X and Y plane, and then you can also rotate it that way to align that one as well. So then you can have this alignment and that alignment on the spindle itself. So that's the whole idea for this system. But obviously these are two faces, and the two faces, obviously when you add parts, you are reducing rigidity of the system. So by lapping these two together, we will reduce the amount of high spots on one of these or both of these, and we will create the best mating phase between the two. And when you do that, then all of the machining vibrations and the machining forces will pass from this to this and from this to the granite. That's the idea of lapping. So I will allow for, I need to clear this desk, and then I need to do a bit of preparation. But then when I do that, I will create another live session, and then perhaps in 45 minutes, an hour, maybe an hour and a half, I will go live again, and we will lap these two faces together. So let me just bring this up. Okay, so thank you for watching this episode, and if you would like to see some lapping, this is going to be my first attempt in lapping. I've seen a lot of videos online, and but this is going to be the first time I'm going to do this myself. So come back in about an hour or so, and I will create another live episode, and you just need to tune in and watch that. So that's it. Thanks for joining in, and I'll catch you in the next one. Cheers.